For me, the kitchen is like my chemistry lab. This is where I not only pursue my love for cooking, but also get to witness the wonderful processes of chemistry. Like the chemistry of a gas cylinder, also known as LPG or liquefied petroleum gas. How does something liquefied manifest itself as a flammable gas? That's what I will be talking about today. Welcome to your personal guided tour of the wonders of chemistry. Today we will study about thermal energy, intermolecular forces, and the relationship between them. We will look at the effect this relationship has on the states of matter and their melting and boiling points, sublimation and compressibility. Finally, I will show you how to solve important questions in exam Decoded. One of the earliest classifications we learnt as science students was the three states of matter. We know that matter can be classified as solids, liquids or gases, like this soft drink. The bottle is a solid, but what can be said about its contents? Obviously it has liquid, but it also has gas in it. If you recall, these three states of matter have very different molecular arrangements. Here is a glimpse of each of them. Solids have tightly packed molecules. Liquid molecules are loosely packed and have free space present between them, and gaseous molecules have very large spaces present between the molecules. Each of these arrangements determines the properties of the respective states. Now, not only do we find nature abound with these three states of matter, we can also convert one state into another. I am sure you have seen this happen in your day-to-day life. So let's uncover the science behind it. One of the easiest methods to convert liquids into vapor or gas is by heating. Heating increases the temperature of a substance, and this increases the movement of molecules. This movement of particles is known as thermal motion. The energy of a body arising because of the motion of its molecules is called the thermal energy. So we can say that with increase in temperature, thermal energy increases. Thermal energy will be highest in gases, then liquids, and least in solids. The other factor which affects the states of matter is intermolecular force. If you recall, intermolecular forces are the forces of attraction and repulsion between the interacting particles. And full marks to you if you remember that attractive intermolecular forces are called van der Waals forces. Van der Waals forces are of three types: dipole-dipole forces that exist between polar molecules, dipole-induced dipole forces that exist between polar and non-polar molecules, and London or dispersion forces that exist between non-polar molecules. You have also studied a special type of dipole-dipole force called hydrogen bonding. That is the attractive force which binds hydrogen atom of one molecule with the electronegative atom of another molecule. As you can imagine, the intermolecular forces are strongest in solids. They decrease in liquids and are the weakest in gases. Can you predict what kind of effect thermal energy will have when coupled with intermolecular forces? In a gas, the intermolecular forces are weakest, but the thermal energy is the highest. In solids, the intermolecular forces are the strongest and thermal energy is the lowest. If I apply heat or thermal energy to a solid, it begins to weaken the intermolecular forces of attraction. This causes the molecules to separate from each other. As the molecules separate, they acquire more free space between themselves and convert into a liquid. The energy required to convert a solid into liquid is called its enthalpy of fusion. It is defined as the enthalpy change that accompanies melting of 1 mole of a solid substance in standard state. This is also called standard enthalpy of fusion or molar enthalpy of fusion. Now, what would happen if we continued to supply more heat? That's right, liquid will be converted into gas. This energy required to convert liquid into vapor is called its enthalpy of vaporization. It is defined as the amount of heat required to vaporize 1 mole of a liquid at constant temperature and under standard pressure. You should know that the value of enthalpy of vaporization is greater than that of enthalpy of fusion. What does this mean? It means that the energy required to convert liquid into vapor is greater than the energy required to convert solid into liquid. That concludes the first phase of today's discussion. To proceed to the next phase, you need to answer the following question. What is the other name for dipole-dipole forces? While you mull on that, I will take a short break. Welcome back. Before the break, I had asked you, what is the other name for dipole-dipole forces? The correct answer is XII forces, named after the Dutch physicist Willem Hendrik XII. Let's begin with the study of melting and boiling points. The melting point of a solid is the temperature at which a solid becomes liquid at standard atmospheric pressure. The boiling point of a liquid is the temperature at which a liquid boils at a fixed pressure, especially under standard atmospheric conditions. Now, both melting and boiling points depend on the size of the molecules as well as intermolecular forces of attraction acting between them. Let's first study the effect of size on the boiling points of various substances. As you can see, the greater the size of the molecule, the higher is the boiling point. Why? Because more thermal energy is required to weaken the attractive intermolecular forces. So oxygen, which is larger and has a molecular weight of 32 grams, shows a higher boiling point than nitrogen, which has a molecular weight of 28 grams. You must also note that if intermolecular forces are weaker, the boiling point will be lower, and if intermolecular forces are stronger, then the boiling point will be higher. A similar trend is observed for melting points also. Now, on the basis of this key learning, you can easily tell me which has a higher melting point, hydrogen fluoride or hydrogen, and why. To answer this, first look at the types of intermolecular forces acting on the molecules of both the substances. While hydrogen bonding is present in hydrogen fluoride, dispersion forces exist in hydrogen. And as you know, hydrogen bonding is stronger than dispersion forces, therefore hydrogen fluoride will have a higher melting point than hydrogen. I hope that makes the effects of thermal energy and intermolecular forces absolutely clear. So are you ready for some questions? Listen carefully as I reveal some of the examiner's most favorite problems. Just remember that if you are asked to compare the boiling or melting points of two substances, then you simply need to analyze their size and intermolecular forces. If either or both of these parameters are higher in one substance, that substance will have the higher melting point and boiling point. But besides melting and boiling, matter also has another process of conversion, where thermal energy weakens intermolecular forces of attraction to bring about phase change. I am talking about sublimation. In this process, a solid changes directly into its vapor phase without passing through the liquid state. I am sure you have observed the burning of camphor, where the white solid goes into vapor form. Another example is dry ice, which is used by ice cream vendors to keep the ice cream cool. Next time you buy an ice cream, you can observe the vapors of dry ice escaping. If you are asked to name an example of sublimation, in the exams you can also mention the formation of pure phthalic anhydride from phthalic acid. Take a look at how this takes place in a lab. This is done by heating phthalic acid in a china dish on a burner, which has a cardboard with a hole in it. This is covered with an inverted funnel with a cotton swab blocking its tip. You will find that crystals of phthalic anhydride collect on the inside of this funnel. It is time now for a query from a young student.
What is the process called to overcome the intermolecular forces of repulsion?
Yes, there is. And the process that illustrates this is called compressibility. As the name suggests, compressibility of a substance is achieved by reducing the distance between the molecules of that substance. Compressibility increases the magnitude of repulsion between the molecules. In solids and liquids, since the distance between the molecules is small, you can imagine how difficult it would be to compress them. But this is not the case with the gases. In fact, gases can even be compressed into their liquefied form. Does the word liquefied ring any bells for you? That's right. Think back to my kitchen and the LPG gas cylinder. This cylinder actually has flammable gases like propane and butane under very high pressures, which convert them into liquid form. This is what allows you to get a large amount of gas compressed into a relatively smaller space. A word of caution: don't experiment with the gas cylinder in your home, because it might develop a leak. Since it contains very flammable substances, it could be very hazardous if handled incorrectly. On that note of caution, I will take a break. When I return, we will see what to be careful about while writing your exams in Exam Decoded. Welcome back to our session on the effects of heat on matter. We have been studying the dynamics of various phase changes, and here are the main points of what we have learned. The three states of matter are the result of a balance between intermolecular forces and thermal energy of the molecules. Higher melting and boiling points of substances are due to larger size and intermolecular forces. Intermolecular forces are weakest in gases, stronger in liquids, and strongest in solids. Thermal energy is the strongest in gases, weaker in liquids, and weakest in solids. Solids and liquids are difficult to compress whereas gases are easy to compress due to weak intermolecular forces of repulsion. Ready to convert these principles into top scores? Exam Decoded shows you how. Excellence in exams is a goal shared by many, yet not everyone achieves it. Exam Decoded promises to give you the extra edge you require to fulfill this goal. Let's begin with our customary rapid fire round. You should be familiar with the rules. I will ask you a total of 5 questions and give you 5 seconds to answer each one. If you get them right, give yourself 1 mark for the correct answer. After the round, I will help you understand how these scores should influence your preparation strategy. Ready to begin? Here is your first question. In which state are the attractive intermolecular forces strongest? A. Solid, B. Liquid, C. Gas, D. Plasma. The right answer is A. Solids have the strongest intermolecular forces of attraction and are the most tightly packed. Complete the sentence for your second question. Stronger the intermolecular forces in a substance, A. Higher is the boiling point, B. Higher is the vapor pressure, C. Lower is the boiling point, D. There is no effect on boiling point and vapor pressure. The right answer is A. Your third question is, which has the highest boiling point? A. Methane, B. Hydrogen fluoride, C. Chlorine, D. Helium. The correct answer is B. Hydrogen fluoride. The fourth question is, ammonia's high boiling point is due to dispersion forces. Is this true or false? The right answer is false. Ammonia's high boiling point is due to hydrogen bonding. Now for your last question. Gases can be easily compressed. True or false? That's easy. It's true. Alright. Now total your marks and have a look at the scorecard. If you have scored 5 on 5, then you are a high flyer, well on your way to being a topper. Don't lose momentum and keep working hard. If you have got 4 or 3 on 5, then you are an achiever. You have grasped the basic principles and need to put in a bit more practice. If you have scored less than 3, then you might benefit from extra tutorials and practice tests, which is just what we offer on www.topperlearning.com. So log on and reap the benefits of our exam guidance. For now, let's take a look at the types of questions you can expect in the exams. The unit states of matter, gases and liquids is critically important for your preparation as it accounts for 5 marks of the total. As far as the topic effects of heat on matter is concerned, you can expect short answer type questions for 2 or 3 marks. Most frequently, you will be asked to solve complex questions by using the concepts you have learned. This means that most questions pertain to conceptual ability. You could get a 3-mark question like this one. The boiling point of hydrogen fluoride is lower than that of water. Give reasons. To score full marks in this question, you must first give the diagrammatic representation of hydrogen bonding in both water and hydrogen fluoride. This will give you 1 mark. Now you should state that the overall strength of hydrogen bonding is determined by the strength of the individual bonds and the total number of bonds which can be formed between the molecules. This is worth another mark. Then explain that each HF molecule has 2 hydrogen bonds. On the other hand, each water molecule forms 4 hydrogen bonds. This leads to a higher boiling point than that of hydrogen fluoride. This is the final part of the answer and will fetch you 1 mark. That was all the advice I have to give you. But I have one more resource that can give you great tips for the exam. Let's meet today's expert.
Hello student, I am going to discuss the important point for the topic you have studied so far, that is the effect of heat on matter. As you know, there are three states of matter: solid, liquid and gas. In solid, the intermolecular forces are stronger. We can define melting point as the temperature when the solid and liquid state coexist together. The boiling point can be defined as the temperature at which the vapor pressure of the liquid is equal to the atmospheric pressure of the liquid. When we heat the solid or liquid or gas, the molecules start colliding with each other. Due to this, they create a thermal energy due to heat. This energy is called thermal energy, and this is maximum in gas and minimum in solid.
With that, it's time to round up today's chemistry session. I hope you have enjoyed studying the interplay between two of nature's most fundamental phenomena, thermal energy and intermolecular forces. Now it's up to you to take what you have learned and create your own roadmap to success. All the best.